is NURUL, AINA, NABIHAH, BINTI, HAMDAN. So today I'm going to present to you the first part of this subtopic, 5.1. Have you ever heard of Sir Isaac Newton? Sir Isaac Newton made one of the important discoveries in mechanics, calculus and optics. He is one of the greatest mathematicians, physicists, astronomer, theologian and author of all time. How did it started? It is inspired from Newton's observation of apple falling from a tree. Newton realized that the earth must be responsible for the apple's downward motion, after considering why it never dropped sideways, upward, or in any other direction except perpendicular to the ground. In this chapter, we will be focusing on Newton's law of universal gravitation. Newton's law of universal gravitation states that every point mass in the universe attracts every other point mass by a force pointing in a straight line between the centers of the mass, and this force is proportional to the masses of the objects and inversely proportional to the square of the distance between the centers. The formula used for universal gravitation is F equal to G m1 m2 over r squared. The Earth is considered as mass capital M and radius r capital R, and r is also assumed as the distance from the center O to a test particle P of mass M. We also assume that r is bigger than capital R. The Earth is split into circular ring of width r delta theta as shown in figure below. Density is ρ equal to m over v, or ρ equal to m over a. The area of circular earth ring is a equal to 2 pi r squared sin theta delta theta. Delta m is equal to ρ 2 pi r squared sin theta delta theta. The force delta Fq exerted by the entire ring is the magnitude Fq is obtained by adding the components delta Fq cos phi in the direction of PO, and then we get delta F equal to Gm delta m over d squared cos phi. From the equation delta F equal to Gm delta m over d squared cos phi, we will have to substitute the value of delta m, that is ρ 2 pi r squared sin theta delta theta, and in the end, we will get delta F equal to Gm ρ 2 pi r squared integration from pi to 0 sin theta cos phi over d squared d theta. S is the distance PQ as shown in the figure. By taking the limit delta theta and integrating it, the magnitude of the force exerted on P can be determined. Using the law of cosines, we can know the equation that is d squared equal to r squared plus r squared minus 2r r cos theta. S squared is also equal to d squared. Next, we will have to differentiate both sides and rearrange the equation to get sin theta.
Hello and good morning, students. My name is Miss Natasha, and today we are going to continue our lesson, which is gravitational force between a uniform sphere and a particle. Before we get started, I want to ask you guys, do you still remember this triangle?
Yes, Miss.
Good, Adam. I will remind again to you guys. We will use the law of cosine in order to continue this equation. Can someone tell me what is the formula for law of cosine?
The formula is c square equal a square plus b square minus 2ab cos c.
Well done, Sarah. By using that formula, we can insert capital R, small r, d and phi into it to get the angle between moon and particle A. After that, we will get this type of equations. Next, you need to rearrange the equation until you get cos phi, because this equation we will use in the next section. Hence, we will continue to find the formula for Newton's law of universal gravitation, which is our main objective. As you can see here, this equation or formula is quite familiar for us because we have learned in previous lesson. So the first step is you need to insert equations sin theta, d theta and cos phi as we have found before into this formula, which is force exerted on the moon. and then you will get the second equation. And please don't forget to change the limit of integration from 0 pi to small r minus capital R and small r plus capital R. After we have done all the integration things and simplify the equation, we will get this equation. Delta F equal to Gm rho 2 pi r square over 2r square r times with 4r. Since the mass of Earth or shell m equal to 4 pi rho r square, we can replace terms in the equation 2 pi rho r square equal to m over 2. After that, we will get the final formula of Newton's law of universal gravitation, which is delta F equal to Gmm over r square. I think that's all for today. Thank you for your attention and see you when I see you.
Hello, in this session, you will meet Wani as she go through the process of answering example questions. And like others, Wani also struggles with answering questions. So Wani gets started right away. Question 1. To answer this question, we use universal gravitation formula F equal to G m1 times m2 over r square. Substitute all the given constant, satellite masses and distant masses into this formula to calculate the answer. We know that the force between two satellites is 2.5 times 10 power negative 10 Newton. Question 2. We can use the conservation momentum to solve this question. We know the masses for both satellites are equal and the second satellite is initially stationary. Now, we need to find the velocity of the first satellite. Since the satellite is in orbit, we need to find the tangential velocity. We can do this by finding the centripetal acceleration from the centripetal force. We know that the force due to gravity of the Earth on the satellite is the same as the centripetal force acting on the satellite. That means Fc equal to Fg. Solve for Fg for the satellite. To do this, use law of universal gravitation. Insert all the values given in this formula to solve the force of gravity. After sub all the given constant, satellite masses, Earth masses, distance into this formula, we can calculate the gravitational force. The gravitational force Fg is 6.87 Newton. We can find acceleration using this force value. Our two forces equal and solve for the centripetal. Fg equals to Fc. Fc equals to msac. We have Fg value, so we just need to insert Fg in Fc, which is 6.87 Newton equal to msac. Ms is the mass of satellite, so we know that AC is equal to 2.7 times 10 power negative 3 m over s squared. We can find the tangential velocity using the equation for centripetal acceleration. The formula is AC equal to v squared over r. After substitute AC value and radius value, we finally can figure out the velocity of the first satellite. The velocity that we get is v equal to 5.33 times 10 power 7 meter per second. Now, we can plug initial velocity obtained into the equation for conservation of momentum to solve for the final velocity of the two satellites. Therefore, the resulting velocity v3 is 2.67 times 10 power 7 meter per second.